questions? What kind of questions do we have from 157, 158 that I can help you with? These are the time plot ones, right? Yeah, we recorded for you. Yeah. 11, yeah. All right. Number 11. Says, if you were to make predictions for the year 2020, would you trust this regression model to make this prediction, or do you think you could be more accurate? All right, so our graph that's shown to us kind of looks like this, where at this point it's at 2010, and they want to know, obviously, we've passed 2020, but they want to know, do we feel comfortable enough making a prediction here, okay, which in this case would be extrapolation. But we said extrapolation is not to be trusted, but a lot of times it becomes the only tool that we have. So this was the debt, the total debt to gross domestic product, so GDP. So would you feel that this graph is going to suddenly do a downward spin at this point, kind of go medium, keep going up? I would say it's probably going to go up, even though it is extrapolation. There are definitely things I would take a look at if you were to have other predictions from that. So other things that you could kind of look at with it, would you trust, from 1920, they're kind of thinking it might be something like this if you were to if you're going to try and build it. I don't know if I would trust it entirely. I don't know if I'd put all our stock into it. Obviously, if you make a prediction and then that prediction is relatively accurate, either you got lucky or you're on something. Any other questions off 157, 158? Going once? Going twice? Sold. Okay, my friends, I'm going to be on page 159. So I made a decision. We're going to go through this as a class. This will be recorded because we do have a quiz on Monday. So quiz Monday. Do you have your half sheets? Are you starting it? Hopefully you will. The nice thing about the quiz is you're not necessarily going to have to use Desmos at all to plot these, which is fine. But so problem number 1 says create a time plot of the unemployment rate, list the axes. So if I were to have put this in just by hand, it looks like 2014. Why did it go backwards? 2002 is over here, and then 2014 is over here. And if we were, this is our time, and we wanted to do unemployment rate. And again, I could do this on Desmos pretty easily. The unemployment rate looks like it goes from there to 10, so maybe I count by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unemployment rate percents. So you could go at 2002. It's kind of up here. Then it kind of creeps up a little bit. Creeps up a little higher. Then drops to the 8. A little bit lower. Peaks back up a little bit. Lower. So basically, this is what it's doing. So if I went and connected these dots, which you're welcome to do. So some of the trends that you might be looking at, something happened here, okay, to really drop the unemployment rate. But this at 2010 is starting to show an upward trend. Can we guarantee it's going to continue to go up, or will it go back down? I can't make any of those guarantees with it, because if we take this out and again we realize we're ending at 2014, so we should find the data for 15, 16, 17, 18, 19, 20, 21. 22 will be released at the end of the year. Okay, a couple sentences describe the time plot in context. So one thing that you could say is up till 2005. So it's from 2002 to 2005. It was going up. Other things you could probably indicate about this, you could say, so after 2005 to till 2014. So 2005 to 2014. It appears it's going down or it's lower. So those are all things that you can kind of say about it. Use your calculator to create a regression line for this data. Friends, again, you are, hang on, I have to look at this real fast. Yes, we do have that. There's, hang on. I was right. There is not a regression thing you have to do on desktop. All right, so skip number 3. Skip number 4, 5. I'm just seeing what's on here. Okay, so I'm on page 160, and this is definitely stuff that I saw that will be on the quiz. No, I just took a quick glance at it, and it's not related to the quiz on Monday. Do what's that? Through 11. Yeah. I mean, there's some terms up through 11 that might be used. We're not comparing off of Desmos. But I know on page 160, when I get down to number 12, they give us y hat equals 22.25624 minus 0.026551 x. And they tell us that y hat is the drop in blood pressure. Yeah, 3 through 11, just kind of jump past it. I won't have it on the quiz. And then X is new medication. And then they tell us we have an R value of 0.794. Okay? So a few things to look at. For number 12, it says calculate the residual. So we want to find the residual and using capital R. If somebody took 150 milligrams somebody who took 150 milligrams resulted in a 10-point drop in blood pressure. Okay, so that's basically, they observe that. Okay, they have a line of best fit that fits with this. So this is like 22.2, and then it's dropping, okay, at a certain rate. So that's, just kind of sporadically what's happening. And they're saying, hey, somebody took 150 milligrams. Okay, so it's possible the dot's above this or below this. I don't know exactly where it is yet. Those blue dots are either from these points. So what we want to do is we want to actually take a look at, if I were to take the 150 and plug it into this top equation, will somebody please do this on your calculator or your phone? Minus 0.026551 times 150. So 0.026551 times 150, and then whatever that is, subtract it from 22.265624. Anybody with a calculator would be great. I don't have a calculator. Yeah, your phone's sitting in your hand. Honestly, you could plug that into Desmos. It would do it. Just plug it into one of the equation lines and just do 22.25624 minus 0.026551 times 150. Do we get an answer? So this is a prediction. 50.27? 18.27? Cool. All right. So what this value is, this is the point 150, comma 18.27, which is what we are predicting the medication is going to do. But we made an observation, resulted in a 10-point blood pressure drop. So we made this observation here, which is 150, comma 10. Okay, so we're not using that one. I just had to use the line of best fit to determine it. Hey there. Thank you. So when we do our prediction, what do? We do the prediction. What do we do? So I want to find the residual, which is going to be our observed minus our predicted every time. So remember, predicted comes from the line of best fit. So my observed, my Y value is 10. My prediction is 18.27. If I subtract those, I get negative 8.27. So that's my residual. That's the distance right here on the line. Okay? If you're a patient receiving this medication, would a positive or negative residual be more beneficial? So number 13, if you are the patient, do you want a positive or a negative residual? What do you think? Good. I want negative. That means you did better than what was predicted. So you want negative, in this case, is good. Okay? You did better than expected because your data is below it. Okay? Is this regression a good fit for the data? Explain how to give the information. Okay, so for number 14, or excuse me, number 12, is our information good? Okay, we have an R value of this. Okay, which up until last week, we had a kind of a smiley face for this, right? But I don't have a way at this point, I don't have a way I don't have a way that I can figure out the residual graph. I don't know how to do this with the information that's given to us. I mean, not because I can't do it. It just can't be done. So you can't tell. Let's see, 12, calculate. Oh, wait, 12, 13 in this patient. Okay, I'm sorry. Did I answer 13? Answer 13. This is number 14. I'm sorry. Is this regression line good fit for the data? Explain. Okay. So because I can't do this based on what I have, this is my only indicator, but now we have a second test that knows what is the residual graph. What are things that you're looking for on the residual graph that you don't want to happen? Well, you don't want a residual graph to have some sort of pattern to it. You don't want it to be a parabola. You don't want it to be like a fan, whether it's going from small to large as you go left to right or large to small as you go left to right. So this right now for number 14, we don't have enough information. Up until last week, we were able to say we felt pretty good about the R value. But now we have a secondary test in place that is going to take away from us. All right. On number 15, again, you're not going to have to enter the data into the calculator. What I'm going to do is let me give you the equations that you would be given. So teen smoking would have resulted in this. So this is years, and this is percent. And then we also have, so typically we would have plugged the data into Desmos and figured out our y hat. But we're going to give you the y hat equation. So this is the adult is 77.8.1 minus 0.3775 x, and again, that's a year. Okay, so you have these two equations that are given to you. Okay, the teen has an R value of negative 0.912. The adult has an R value of negative 0.970. So far, we have a good R value. Shows a negative regression line. So it just means our data falls along this regression squares line pretty nicely. Okay, so we want to then predict the year 2020 for the teens and the adults. Okay, so what we're going to do is I'm going to go 2088.835 minus 1.03 times 2020. If you did that math, it's going to come out to 8.235%. I'm just doing the math quickly for you. And then the adult is going to be 77.8.1 minus 0.3775 times 2020. And again, if you plug that into the calculator, this is going to come out to 15.55%. Okay, so this is public health officials monitor the smoking rates among students and adults. Rates for both are provided. We created two different linear equations. We will give you the linear equations. We will give you the R values on the test. You don't have to go and do it on the calculator. It says that in 2020, you're going to have 8.2 roughly % of teens that are smoking. In the year 2020, roughly 15.6% of adults would be smoking. Do we trust these predictions? Okay. So am I going to trust these predictions? Is that the next question? Predict 2020. Do we trust? So this is I guess, number 16 as the red here. Number 17. Trust or no trust? So it is extrapolation. And we have been saying that extrapolation is not to be trusted, but the correlation is strong. The downward trend might be consistent over time. So it's possible that these are good predictors, okay? Because these values are strong. And again, we didn't plug it in, because if we plugged it in, we could go ahead and find the not the regression, it's lost the word. The residual. We could have seen the residual graph if we truly did plug it in, but I'm not plugging it in on the calculator. Okay? It is extrapolation. This is possible. It doesn't have to be exact. Other things to know for Monday's quiz would be, if I were to give you -10. If I were to give you this, do you feel that's a good residual graph? Good or bad? Do you see a pattern to it? No. So there's no pattern. This is good. What if I had a residual graph? I'm just going to make different color. I was doing this. Is that purple residual good? Yeah. The purple is bad. Purple, bad. I have a pattern. Okay? So you might have to answer the question, hey, do you trust this? Is this a good residual? Why or why not? No. The red is good because I don't have a pattern. Purple is bad because I have a pattern. What about this residual? Is that green a good? The green kind of fans out, right? So green is bad. There's a pattern. It fans out, something like that. As I go from left to right. All right, so my friends, come Monday, we'll have a quiz. I think it's 22 or 23 points, so about the same size as the last one. Do you know what you're putting on your half sheet of paper? Well, it's going to be over, the majority of it is over 2.7 to 2.9. But so this is the majority of it, but because we had sections 2.1 to 2.8 as well, or to 2.6, I would say put your eyes on some of the definitions that might have come out of 2.1 to 2.6. Sound like a plan? So now, if you're here, there wasn't a video for you to watch because I did it for you. Sorry. Good.